Good morning, sir. Myself Harshita, bearing a roll number 24405E0203 from Triple E branch. My subject name is CVNM, Complex Variables and Numerical Methods. So my topic is about Picard's method. So coming to the Picard's method of successive approximation. So let us consider dy by dx is equals to f of x comma y with an initial boundary condition y of x naught is equals to y naught by the Picard's method to find out integral function between the limits x naught and x. So of the nth approximation can be defined by, this is the formula of the Picard's method of successive approximation. Y naught is equals to y naught plus integral of x naught to x f of x comma y power n minus 1 into dx. So where n is equals to 1, 2, 3, 4 and so on. So the above procedure will be continued until it has desired accuracy value. So coming to the problem, solve the differential equation dy by dx is equals to x plus y and the boundary condition y of 0 is equals to 1. So obtain the value, so I can here given only one value 0.1 using Picard's method only. So on compare, check the answer with the exact solution. So coming to the solution, given differential equation dy by dx is equals to x plus y is equals to f of x comma y. Given boundary condition, what is the boundary condition here? Y of 0 is equals to, according to the question, they given differential equation and boundary condition. So next coming to the solution, compare the given boundary condition with y of x naught is equals to y naught. So then we get x naught is equals to 0, y naught is equals to 1. So by using the Picard's method of n subtraction, we already know that the formula of this is for the formula for Picard's method. So if n is equals to 1, then what is the formula? Here in substitute the value of 1 in place of n. So here y1 is equals to y naught plus x naught to x, integral of x naught to x, f of x comma, here n minus 1 is 1 minus 1 is 0. So this is one. Next, coming to the solution, you know that f of x comma y is, this is the given differential equation. Next, f of x comma y naught is equals to x plus y naught, that is equals to x plus 1. So y1 is equals to 1 plus integral 0 to x. Here this is the formula x plus 1 into dx. Integral of this one is 1 is x. X is equal x of the integration of x is x square by 2. Then we get this 1 plus x square by 2. Next, same y1 is equals to y of x1 is equals to y of 0.1. We find out the value of x 0.1. By substituting the x value in the place of x, we can place the 0.1. So we get the answer 1.105. So similarly, the procedure will be continued until the same approximation will be find out. Next, if n is equals to 2, then what is the formula? Here in place of n, we can put the 2 value. So here is 2, here is n minus 1 means 2 minus 1 is 1. Next, we know that the formula f of x comma y is equals to, given differential equation is x plus y. Next, f of x comma y1. What is y1? Already we will find out in previous we can find out the y1 value. Substituting this value, again we can get the equation 1 plus 2x plus x square by 2. So therefore, in the y2 formula, we can place here, substitute the value, and 1 plus x plus 2 x square by 2 plus x cube by 6. So by in place of x, we can place out the 0.1. So what is the value? 1.110. Similarly, if n is equals to 3, so we didn't have any here y1 is 1.105, y2 is 1.110. There is no desired accuracy value, so we can go through n is equals to 3 also. This is the y3 formula. Next, in place of y, we can find out y2 value. So what is y2? In previous, we can find out the y2 value. Substituting this one, we get the equation 1 plus 2x plus x square plus x cube by 6. Next, y3 is equals to integration of this one. So 1 is x constant integration x. Next 2 into x, 2 into x square by 2, x cube by 3. Here x cube by 6 means differentiation integration of this one is x power 4 by 24. So by substituting all values, we get the formula 1.1110. So y2 also we get the same value only. So until this, so the two y2 and y3 got the same desired accuracy value. So that's why when stop here only. Next, in question they asked to compare the check the answer with the exact value also. So for this we can find out the value given that this is the differential equation. So they can all written as dy by dx minus y is equals to x. So putting by substituting the p is equals to compare this one with this one. This is normal ordinary function, normal ordinary function. So p of x is equals to minus 1, q of x is equals to x. Integral formula, we already know that one, integral formula. In here in place of p we can put the minus 1 value, this way e power minus x, we got the answer e power minus x. So y of integral formula is integral of q of x, integral formula into dx plus c. So by substituting all values we can got the answer. Next, integral of UV rule, this is the UV rule, we already know that one. So by substituting the by putting all the values in the integral form, we can get the answer y is equals to minus x minus 1 plus c into e power x. By putting the boundary condition, we can find out the c value also. So boundary condition, what is the boundary condition? Y of 0 is equals to 1. By putting x naught is equals to 0, y naught is equals to 1. So y naught is equals to minus x means x value is 0, 1 plus c, e power x value is 0. So e power 0 is 1 plus c plus c. Next minus 1. Here is 1. Next c is equals to 2. So by substituting all these values in this formula, minus x means minus 0.1 minus 1 plus c value is 2, e power 0.1. So we can go answer 1.110. So back my conclusion is that therefore numerical value of phi of 0.1 is 1.110. Exact value is also 1.110. Hence they proved according to the Picard's method formula. By using Picard's method formula approximations, we can continue the procedure up to it has desired accuracy only until we can get the answer. So by both are equal, so that we can conclude that. Next, thank you sir for this is my presentation about my Picard's method. Thank you sir.